Dear students, here we will explain the force of gravity and weight. That is what is the force of gravity and what is weight. So here the first question is that what is gravity? The gravity in general, we can explain the gravity in generally that gravity is the force by which the planet or other body draw the object towards its center. The force of gravity keeps all of the planets in orbit to orbits around the sun. So we can say that this is the force of any object or it is the force of any planet, any object which draw the other objects towards the center, and so this is the gravity which is responsible for all planets to move in a circular orbit around the sun. So what else gravity can do? What else gravity do here? This is the visual form of the gravity. Here you can see that it's always directed towards the center. So what else gravity can do? Why do you land on the ground when you jump off instead of floating off in the space? So when you jump off, you can float in the space, but rather instead of floating off in the space, you jump into the land. What is the reason for this situation? And secondly, let's suppose there is another question. Why do things fall down when you throw them or drop them? Why they all will fall on the ground? All things comes down towards the earth. What is the reason? So the answers to all these questions are gravity. So the reason is gravity. So the gravity, we can explain it like the attractive force exerted by the earth on all object, which is called as the force of gravity. This is the attractive force of earth, the force of earth, which is the earth is exerting on all objects. This force of earth is called as force of gravity. Okay, the force of gravity is always directed towards the center of Earth, and it can be represented by Fg. Here, the subscript G represents the force of gravity. So, this is the force of gravity, and it's always directed towards the center of Earth. So, what is the weight? Next question is what is weight? We can define the weight. Weight is the magnitude of the force of gravity. So the magnitude of the force of gravity is called as weight. According to the Newton's second law of motion. So we can apply the Newton's second law of motion for a freely falling object. For free fall object, when we apply the Newton's second law of the motion, according to the Newton's second law, sum of all forces equal to ma. So when body is freely falling, so acceleration will be equal to the acceleration due to gravity. So we can write the Newton's second law as F is equal to mg. So here force is the total force net force is equal to the force of gravity. So this is the force of gravity. Okay. So this is the force of gravity and is equal to mg. Here, thus the weight of an object can be defined as the magnitude of the force of gravity. So magnitude of the force of gravity is equal to mg. So this mg is called as, can be defined as the weight of an object. So it can be defined as the weight of an object. So weight is equal to mg. So here we can know that the value of the g is not constant, rather value of G varies with the sea level. At sea level, the value of G is equal to 9.8 meter per second square. So let's suppose this one is the girl which is standing at the sea level. As we know that the value of G varies with the sea level, and so its value of G is different at the different location. So we can say that G is different at different location. It varies with the center of the earth. So when we go away from the center of the earth, or by increasing the distance from the center of the earth, its value increases. So G, as we know that, is depends on the center of the earth. So when we go away from the distance from the center of the earth, the value of G decreases. Okay, value of G decreases with increasing the distance, with increasing distance from the center of earth. Okay, and its value increases when we come towards the center of earth. That's why when anybody go higher in altitude from the sea level, it faces the weightlessness. So here we can see that the girl which is standing at the sea level. So we know that the value of the G varies with the location. It's not constant at all the location. It's with reference to the sea level, the value of the G varies and is different at different location. And as we know that Fg is equal to mg, the weight is equal to the weight of an object. So the weight depends on the value of the G. As G varies with the location, so weight also depends on the values of G. It also varies with the location. So unlike the mass of the body, you know that weight is not inherent property or internal property of an object. Weight is not inherent property or internal property of an object. Okay, it's not an internal property of objects. So rather it depends on the location. It varies with the value of the G. So here the girl which is standing at the sea level, let's suppose its mass is 70 kg, and here at sea level the value of G is equal to 9.8 meter per second square. So what will be the weight? Weight is equal to the magnitude of the force of gravity. So it's equal to mg, and here m is the 70 kg, and its value of G is the 9.8 meter per second square. So it comes out to be the 686 Newton, and which is almost equal to 150 pounds. So this is the weight of this girl when it is at the sea. She is standing at the sea level. Now let's consider the man which is standing at the top of hill, at the top of mountain. As I have already discussed, that value of the G varies with the sea level. So when man is standing at the top of mountain, here the value of G is equal to 9.77 meter per second square instead of 9.8 meter per second square. So what will be the weight of an weight of this man is standing on the mountain higher than the sea level? So here the weight, which is equal to mg, Again, the mass is the same, as mass is the internal property of any body. So this mass remains the same. So here the value of G is 9.77 meter per second square. So its weight comes out to be the 684 Newton instead of 686 Newton. So weight is less than the previous situation when the girl was standing on the sea level. So again, as we can go to another example. Let's suppose any object which is at the surface of moon. At the surface of moon, the value of G is much less than the other two situations. Here the value of G is 1.63 meter per second square. So what will be the weight of object which is sitting at the surface of moon? So when the object is at the surface of moon, then its weight will be equal to mg. So mass, again, either it is on the earth's surface at the sea level, either it is object is at the top of mountain, or it is or object is sitting at the surface of moon. Its mass will remain the same because it is the internal property of an object. But here the value of the G at surface of moon is 1.63 meter per second square. So when we calculate these digits, so it comes out that here the weight of an object which is sitting on the surface of moon is much less than the weight when it was at the sea level, or when a man was at the top of mountain. Although the mass is the same, but the weight is different in all three situations. So weight of an object depends on the value of the G. It varies with the location. So it's not constant at all locations. So thanks for watching. For more videos, please subscribe our channel.